To start with a matrix, matrix are always named by capital letters. Let's say matrix A. Everything inside the matrix going across the matrix are rows. Anything going down is called a column. A spot in the matrix is named by first whatever row it is in, followed by the column it is in. So matrix A, the first spot here would be considered a row 1, column 2, or A, which would be row 2, column 1, or A, row 3, column 1. This next spot here would be A, row 1, column 2, row 2, column 2, row 3, column 2, A, row 1, column 3, row 2, column 3, row 3, column 3. Now, this here would be called a 3 by 3 matrix because it has 3 rows and 3 columns. Now, if we go back to what we talked about before as far as we're going to use this to solve systems of equations, let's look at x minus y plus 2z is equal to 6. 2y minus z is equal to 7. And z was equal to 5. We have several different ways we can write this. First, we can start with the coefficient matrix. All the coefficient matrix is you take whatever the coefficients of the different variables are and write them down. So a coefficient matrix here would be just 1, 0, 0, -1, 2, 0, 2, -1, and 1. Now, what we're going to use more of is what is called the augmented matrix, which is where you take all of the coefficients that you have and the row of what those were equal to, which in this case was 6, 7, and 5. And again, this is called my augmented matrix. Now, the entire goal of using what we're doing with the augmented matrix is to go ahead and get down to a point where you can look at the augmented matrix and see the different solutions of the variables. So what this gives us with this one is that this would be my x column, so this matrix gives me x is equal to 2. This is my y column, and that tells me that y is equal to 6. And this is my z column, which tells me z is equal to 5. So the goal of what we're doing by trying to write a matrix is get the matrix to look like this, and this is called reduced row echelon form. So let's go ahead and start looking at a question of how we're going to use this. So we have 2x plus 2y is equal to 6. I have x plus y plus z is equal to 1, and 3x plus 4y minus z is equal to 13. So to set up this matrix, you just take all of your different coefficients. Now remember, for the first one, that's going to be 2, 2. There is no z value, so that will be 0 and 6. The second equation gives me 1, 1, 1, and 1. And the third equation gives me 3, 4, -1, and 13. Now, our whole goal with doing this is we want to go ahead and first priority is to turn this into a 1, that first spot. After that, then you're going to turn the next two pieces underneath it to 0 and 1. That's our first step. Then this step 2 is to turn this next place into a 1, and then go above it and below it to turn that into a 0. And the next piece here, turn this into a 1. Once we have that, we will get that value, let's say, and we'll know what z is. Once you get in the matrix, see. So what we're going to go ahead and do here is we're going to move to the next page and turn this matrix into its reduced row echelon form. So the first thing I want to do here is, my first step is to interchange row 1 and row 2, and that's because ideally the very first thing I always want to do with the matrix is turn that first spot, row 1, column 1, into a 1. So I will go ahead and rewrite this with my first row of all 1s, my second row with 2, 0, 0, 6, and 3, 4, -1, and 13. Now, the next piece after that, I want to go ahead and take row 2, multiply it by 1/2, and again replace it. If I do that, my first row is still all 1s. But now I'm taking 1/2 and multiplying it times every single thing that I have in row 2. When I do that, I get 1, 1, 0, 3, and my row 3 stays the same. My next goal that I have with this is to turn that second spot into a 0. So row 2, column 1 needs to be turned into a 0. The way I'm going to do that is to go through and take I'm going to go ahead and take row 1. I'm going to add that to -1 times row 2 and replace row 2 with this. So row 1 is just right now 1, 1, 1, 1. I take -1 and multiply it times row 2. This gives me -1, -1, 0, and -3. When I do that, that becomes 0, 0, 1, -2. This piece is now going to become my new row 2. So row 1 stays the same. So does row 3. So that's 1, 1, 1, 1. Row 3 is 3, 4, -1, and 13. But my new row 2 is 0, 0, 1, -2. And this is extremely helpful because let's look to see what this means here. I'm going to go ahead and change the order with this matrix and swap row 3 and row 2 around. And when I do that, what I end up with is still have a row of 1s here. But when I swap those around, 3, 4, -1, 13, and 0, 0, 1, -2. Now this tells me something really important, because if we remember that all of these pieces mean this is x, y, z, and equal to some constant with the coefficients in the matrix being the constants, what this gives me right here is that z is equal to -2. I'm going to go ahead and finish working on this, so we're going to go backwards for a step and go back to what we were trying to do before. And again, the first goal here is now the next thing I want to do is I want to turn this spot into a 0. How do I do that? I do that by taking -3 times row 1, adding it to row 2, and then it will replace row 2 with all of that. So -3 times row 1 is just -3 all the way across. I take row 2, which is my 3, 4, -1, and 13. If I add all of that, that gives me my 0, 1, -4, and 10. So now when I go ahead and replace this here becomes my new row 2. Row 1 stays the same with all 1s. My new row 2 is 0, 1, -4, and 10. Let me just fix this real quick. That spot needs to be a 1. And the last row is still 1 and -2. And at this point in time, this isn't completely reduced row echelon form, but this is as far as we need to go through and solve this matrix. So remember what we said before, that this last row here gave us that z was equal to -2. So now I'm going to go back up into this row. This row gives us the equation that I have 1y minus 4z is equal to 10. So using substitution, I take that z is equal to -2 and plug that inside there. That gives me y minus 4 times -2 is equal to 10. Or y plus 8 is equal to 10. Y is equal to 2. That's the second value that I need. Now I can go through and find out what x is. I find out what x is by using my top row, which was just x plus y plus z was equal to 1. I don't know what x is, but y was 2, and z was -2. So x is just equal to 1. Just make sure that when you're writing your answers that you write all of them as far as a solution set. And our solution set here is 1, 2, and -2.